We have understood clearly how you run a MapReduce job. Can you please repeat with me how you run a MapReduce job? How you run a MapReduce job?
Hadoop jar
Exactly, Hadoop jar.
and the path for the jar file.
Yeah, path where this jar file is located, right?
Yeah,
Maybe this is the path on your local file system that you need to understand.
yeah,
Work slash mapred and what is that? MR jobs,
MR jobs.
whatever the name.
Yeah,
This
jobs.
is,
Yeah,
yeah, this is a file, the path on local file system.
yeah,
If required, we can also specify this path on Hdfs also. Path on Hdfs also can be mentioned. If at all, if your jar file is located on the cluster, you can also specify the path on the Hdfs, nothing wrong. How we do this one, we see. That is only the URL, nothing more than that. You are accessing, how you are accessing your file system. Say for example, in terms of your, yes, you can see here, what is the path you have? Slash user slash Cloudera, right? But before
yeah,
slash user, there is something. See, if you are within the cluster, you can use slash user slash Cloudera. But when you are coming from outside the cluster, when you're trying to reach the cluster, when you're trying to enter into the cluster, you need to have a URL, right? You cannot just enter like that. You need to have a URL. So this is in order to access your HDFS, you require HDFS protocol, like how you have HTTP protocol. You have HDFS protocol, and then you're going to give the IP address and then the port number. And those details will be acquired as part of your, you can see that slash user slash lib slash Hadoop MapReduce conf core-site.xml. If you see this file, you'll be having the URL for your, yes, this is a URL. I hope you are following with me. This needs to be prefixed. What needs to be given here? This needs to be prefixed. Where? In front of the path. You're following with me, friends?
yeah,
So Hadoop jar, suppose if your jar file is located on HDFS, this is what you need to do. Slash tmp slash sandbox slash mrjobs.jar. Make sense?
input path.
Yeah, this is a path. This is a path. This is a path of your jar file. If it is present on
Yeah,
HDFS,
yes,
then word count,
word count.
then slash tmp slash sandbox. What is this path?
That's input file.
Input path. This input path can be a single file,
Yeah,
or can be a directory, or can be a glob. I mean, matches with that pattern. What all the things you have, all can be. Slash tmp slash sandbox slash Mary underscore out. Here, I made it very clear that input path must exist. Output path must not exist. Getting my point, friends? Input path
Yeah,
must
yeah.
exist and output path must not exist. Why output path must not exist? Because we never know for what purpose that output path is being used to store the output of a previous job. We are not aware of that. So that is the reason why we don't want to override the existing paths anytime. That is the reason why we don't do that. So here what we specify, job name. And then we specify input path, and then we specify output path. So this is optional. When this is optional, see why I'm so specific about this one. I told you a number of times, MapReduce is the base. MapReduce is the base. Even in the next session, we start pig. You may be working with pig, but if you see closely, you write your pig script and you run it, it works as a MapReduce job in the background. After that, we move to Hive. There also, we may be under the impression that we are working with Hive, but when you write a Hive query and run that one, it works as a MapReduce job in the background. It's all a MapReduce in the background. So without having clarity on what we are doing with the MapReduce, your entire learning process will be Greek and Latin. That is the reason why I'm focusing more on this one. So we already did that. And here, let me go and see whether the cluster is up and running for me or not. It should be running because the file system is accessible, the Hive is accessible. There are concerning health and bad health. That's fine. And I was checking, friends, whether all services are running on my cluster or not. I think you see the data here. So let's start from customers when we said we have the data here. You want to draw a basic chart for the data, you can have this one. So it works. I mean, it is working now. All the services are up and running for us. That's fine. So let us go to our. So with this, we have understood very clearly how you run a MapReduce job. So any question you have on this one, please let me know, friends. I want to address it before moving on to the next discussion. Hadoop ZAR, specify where your ZAR file is located. That could be your local file system or even Hdfs. You can also keep your ZAR file on the Hdfs. That is also possible. Let us do that now. Go here or do it from this one only, command line only. work/mapred. Hadoop fs-copy from local. What is that? mrjobs.zar /tmp/sandbox. I'm copying it over there, friends. Have a look at this. What is that we are doing? What is that we are doing? We are copying our mrjobs.zar to /tmp/sandbox. Now I want to use that ZAR file to run my MapReduce job. What I do? Hadoop ZAR /sandbox. What is that? mrjobs.zar. Simple word count /sandbox /Mary /tmp/sandbox Mary _out. If any problem is there, not a valid ZAR file. Not a valid ZAR file. Why? No issue. Hadoop ZAR not a valid ZAR file /home/cloudera/work/mapred. So it is taking mrjobs.zar, that path what we are given as. Okay. No issue for that. runs a jar file, user can bundle the MapReduce code in the jar file execute command using. That is fine, but that's not the criteria here. No, you only give the path of the jar file that is present on Hdfs by supplying the Hdfs path, wondering why it is not accepting. It should accept actually. If not, let us see. This option doesn't make sense because we are copying from local file system only to your Hdfs. Because the same is possible when you are submitting a job to your Hadoop cluster using Uzi, we can specify the path of the jar file present on Hdfs. We can specify the path of the, remember this one, Prasad and Ram. When we come to Uzi, we have one more thing that is called Uzi here. As part of Uzi, when you define a workflow, we are going to specify the path of the jar file which is present on Hdfs. We are not going to specify anything on the local file system. So same work on jar file, say mrjobs.jar file only we use. That has been copied into your Hdfs now. That is under /tmp/sandbox. You have your mrjobs.jar. That we are going to specify which is present on Hdfs only. When you go to the workflows and define there, I want to run a MapReduce job. It allows you to specify the path on the Hdfs, but I don't know, 2-3 places it is been mentioned. It is not allowing, but I wonder why it is not allowing. MapReduce job. See here what it is saying. What it is saying here, Prasad?
jar name. You need to specify the jar name in Hdfs.
But it is telling give the jar name that is a path to the jar on HDFS, not on the local file system.
Yes. Yeah.
So slash tmp slash sandbox and we give mrjobs.zar. We got the thing. So we are going to specify that mrjobs.zar only here. And we cannot specify the file on the local file system here. That is why it has been very clearly mentioned. When you put the MapReduce job here, it is asking you to specifically specify the path of the jar file on HDFS, not on the local file system. So I'll talk about that one when we come to Uzi. But for now, as of now, I am not sure. Let me confirm it once again. So according to the 2-3 short things that we have noticed, someone specified that it is not possible. Which is not possible? The jar file that is present on HDFS cannot be run from the command line. So what they are advising is use copy to local command to copy that to your local file system. From there we need to run. But I think the possibility is there because when Uzi is able to run the jar file from your HDFS, definitely we'll have an option. If not, then we follow the same path. That's fine. So specifying the path of the jar file and the job that you want to run as part of that jar file, given the input path and the output path, you are able to make your job to run from your terminal. But usually in your production environment, we never run the MapReduce jobs like this. We always run the MapReduce jobs using our workflow editors only. We are going to define the workflows, and those workflows are going to be, say here you see, you create a workflow and those workflows are available to you, and whenever you want you select the workflow. Here we don't have anything now. I think 1 second. In the meantime, okay. Uzi. So let it happen. So you see closely, you are going to define all your jobs using your Uzi, and through Uzi only we are going to run the jobs, because usually you will not have one MapReduce job that is going to run. You will have a MapReduce job which takes care of something in your actual task. The output of the MapReduce is consumed by your pig script to do further. It produces some output, and that output is going to be consumed by the scoop command to push it to your traditional RDBMS, and from there the analytics are going to run. If you want to achieve this one, what is that? You need to have a MapReduce job, and the MapReduce job is going to take some input and it produces some output. This is what your MR job. It reads the data from HDFS and writes the data to HDFS. From there again, my pig is going to read and produces some output. From here again, my scoop is going to read and send it to my traditional RDBMS. This is my DB. On the top of this one, my analytics are going to run. This is already in place. We need not worry for this part. So when you need to run a MapReduce job, then pig, then scoop, when you need to do all these things, what we are going to do is, we are going to specify all these three in a sequence as part of your Oozie workflow and make that workflow readily available. Whenever you want, you just go there and run that workflow. That's it. Now you can see that here. Going to the workflows. You select the workflow and you click on submit. That's it. You click on the workflow. You define the workflows like this. You select the workflow and click on submit. That has been submitted to your cluster. This is how usually we do it as in the production environment. Maybe when you're doing your experiments and all, when you are developing your MapReduce job independently, you want to test it independently before keeping it as part of your workflow. You may be working with the command line. You may be working with the terminal and all. But in the true production environment, we never do that. All these MapReduce jobs, what all you are developing, and your pig scripts and your Hive queries, your scoop commands, all these things, you are going to arrange them in a flow and make that flow to run. Very rare, one single MapReduce job is going to finish your task. Very rare. Maybe a MapReduce job followed by a pig script, a Hive query, then a scoop command, or a series or a sequence of MapReduce jobs. MapReduce job 1, then 2, then 3, then probably a Hive query. So you are going to define that one based on the task, how you want to accomplish your task. So all that flow we are going to define inside your, if we see this one, it is going to give you the understanding how you define the workflow. You see here, and for this sake you will be having, let me show you. All these are the properties. See here, this is a ZAR, this is a ZAR, where it is been present, MapReduce task, how many it needs to be, and what is a mapper class, what is a reducer class, output map output key type, and your MapReduce output format, input format, what is a partitioner, speculative execution false, sleep, the map sleep, and your reduce sleep. All these been configured by you as properties. All these been configured by you as properties. And this one you are going to submit. Of course, here you have only one MapReduce job. But if required, what can be done is, I think you are noticing here, you want a Hive or maybe a pig script. I think you are noticing here. Okay, that's fine. See that? Immediately we configured a pig script, and the path of the script on Hdfs, where your pig script is located, that also we are going to specify. Not only this one, you want a Hive query, or maybe you see here the scoop command. I think you are noticing here, there is something called a scoop command. So this also you can, what is the command that you wish to run? Scoop import, what is the command that you want to run? That you can specify. So all these into one Oozie workflow. We have only MapReduce job here, but what I mentioned here, a MapReduce job and its output being received by your pig, and its output being received by your scoop, and its output is pushed to the database. So when you want to run these kind of things, what we do is, we may be developing See why I'm giving you this big picture, friends, to make you to understand. As a developer, so your ultimate goal is to do these things. You develop a MapReduce job, you develop a pig script, you develop a scoop command. All these you may be developing independently, but we need to put all these three together to get your task accomplished. And how you put all these three together using your Oozie workflow. And not only this one, friends, not only defining the workflow, we can also make this workflow to run. We can also make this workflow to run based on your, you can see that one here, I'll show you. That is what we call it to be a coordinator job. When you want a workflow to run every day in the morning 5 o'clock, what you can do is you define a workflow and give a scheduling to that workflow that becomes a coordinator job. Anyhow, we are going to talk about this one when we come to Oozie, how you define an XML file and all that stuff. But as a developer, our ultimate goal is to achieve this one. The same Oozie workflow, whatever we are developing now, we add scheduling to that. That's going to become a coordinator job. What is the difference between a workflow and a coordinator job? Coordinator job is going to run based on the time what is being set by you. Every day, 5 o'clock in the morning, it needs to run. Then every day, 5 o'clock, it runs and produces the output in the predefined location. By the time your analysts are ready at the workplace, 7 o'clock or 7:30 or 8 o'clock, they start consuming the data, what is being produced by this workflow job early in the morning, 5 o'clock. So that is what the end goal. So for that sake, we are doing all these things. Whatever we are discussing now, we are doing all these things. Now let me show you how you create a new project as part of the Eclipse. A fresh project we create because we have observed and we noticed. What is that we noticed? How you run a MapReduce job, we are clear. And what code we write inside a MapReduce job, that also we are clear. Mapper class, reducer class, and the driver code. We are clear with all those things. Let me create a new Java project. Please watch this one carefully, friends. My jobs is what I am creating now. My jobs. You want this to be created in your workspace, that is fine. But you want this to be in a different location, you always can specify that. So where it is going to be created now? The project name is My Jobs. Instead of using a default location, I'm specifying my own location here. I'm specifying my own location here.
See, no, sorry to interrupt you. Done.
Yeah, please.
So we're trying to, create a MapReduce job from scratch.
Yes, exactly.
Using this one.
Yes, exactly.
Okay, sure. Thanks.
So what is that you have chosen? You have chosen a Java project and we are given the project name and we say next year. This is all that is going to be generated. What is that? Oh, let me finish. I think in MapRed we have already work/MapRed. We have all these things available. Okay. Create a folder that is my jobs. Okay. New Java project, my jobs. Okay. So next, I think you noticed here earlier and now, I think you see the clear difference. Under my jobs, SRC is going to be created. You want other things to, as of now, we don't need any other. You want to link additional sources or add some other project to this build path and all, you can do that. You click on finish. An empty Java project is being created here with just JRE system library being added. With just JRE system library being added. So to this, what I am doing is I am adding a new Java class, and you need to specify the name of the class, that is word count, and you must specify the package com.myjobs.mapred. In that, the name of the class is word count. So word count is the simple name, and com.myjobs.mapred is the mapred.wordCount is the fully qualified name. So you want to keep a main method, you want constructors and all that stuff. That is all can be done by you. New Java class, and here it is word count. Make sure, friends, that you are going to use this option. Whatever I did now, that you need to use the option. Otherwise, certain options of your Eclipse will not be visible to you. Certain options of your Eclipse not visible to you. com.myjobs.mapred, and I think you noticed here earlier that certain options are not visible to me. Click on finish. So you have your class, you have your main method all been generated. You want to do it from scratch, that is fine. Understanding your mapper, watch there, and you start writing like this. This is all for your main method. So here you can say public static word count mapper extends mapper. Where this mapper is present, actually, you are going to see the error message saying here. What is this mapper? Public static class. So you're going to see the error message saying mapper cannot be resolved to a type. So you need to add a library to your path, that is where go to the build path and say configure build path, and here you need to say add external jars, and you need to specify /user /lib Hadoop MapReduce. Is this? No. Lib. You have something called client here. I think you noticed. User lib Hadoop client. All these are the libraries that are needed for your client. Of course, for just developing your MapReduce job, I don't think we require all these ZAR files. But we take all these are the ZAR files that are needed for developing your client applications, I mean your jobs. But all these are needed for every program, every MapReduce. For this, I think MapReduce client core and job client, and then you have your Hdfs ZAR and your common ZAR. So these will be sufficient, but it will be tough for you to identify which class is available in which ZAR file and all. That is why select all and say OK. And you say OK here. So under reference libraries all been added now. Under reference libraries all been added now. All your reference libraries been added under your reference library section. Now here you will not have that message now anymore. Instead you will be having asking it to import. Earlier it was saying cannot resolve that symbol, but now it is not saying that because we have added the library. In that library, so automatically what happens? Import r.apache.mapreduce.mapper, and you also need to specify add generic arguments to mapper. Okay, then what happens here? It is doing that one. Key in is object, value in is text type, value out is text, and this is int writable. And we need to specify int writable cannot be resolved to a type. So it is asking me from where you want to get the text. You got that one from there, and you want yes. Now you see how closely we are doing the stuff, and inside this one you want to override that method. You always can do that. You want to override a method, you can always do that. Override or implement methods. If you select that one, I want to implement the method here and say OK. I got my map method. Key in is object and value in is text type, and that is what the mapper, I mean the context object, and we don't need super.map and all. Here you start writing your logic. What is the logic that you write? You convert your value into string msg equals to value dot toString. The moment you say value dot, it automatically pops up all the methods that are possible. Select that one, and that's what the beauty part here. And this we start using it as part of your string tokenizer. Tokenizer equals to new string tokenizer, and you press tab here, control plus tab, it is going to give you that new string. You see that one here, tokenizer from java.util, and here we are going to specify message. That is the reason why working with your IDE is always more advantageous. And here I am going to specify private int writable, maybe count equals new int writable of 1. We do that here. Or I also can say whatever the name you feel convenient. whatever the name you feel convenient, but keep appropriate names there. And here you write the logic while tokenizer dot has more tokens. I'm going to specify context dot write of tokenizer dot next token, and that one is going to be occurrence. I hope you are following with me what I am sharing with you here. So the method write is not applicable for the arguments string, no problem. This we are going to convert into write of a new text. I get all those messages from this one only directly. All those warnings and all, we get it from here on. So my word count mapper is implemented. Though it is painful for you to write this kind of implementation, but until and unless you write something on your own, you will not gain the confidence, friends. You will not gain the confidence if you are not going to write this one. So please make sure that you are going to write your MapReduce jobs on your own. You want to see, you want to watch, you want to observe, and then do it here, that is fine. No issue for that. But make sure that you do it on your own. Then only it makes sense. Otherwise, you will not be able to get that. So to make our things simple at this stage, what I am trying to do is the same simple word count, what is being written by us. I am copying that and trying to use it here. I make this as a word count, public class word count. This is a word count mapper. This is the word count reducer, what I am keeping, word count reducer. And here I want this to be word count class, word count mapper, and this is going to be word count reducer. This also is my word count reducer. And here is my new word count. I hope you got everything now. And this is a package com.myjobs.mapred is a package in which you have written this one. If I pass this jar file as is like this, observe this one very closely, friends. If I pass this jar file as is, export jar, say next, and here myjobs.jar, and I say next, next. I keep the main class as word count itself. Then I click on something called finish. I got my myjobs.jar file inside. Look at this one. My jobs star. You have a file called myjobs.jar. You can run this one directly saying Hadoop jar. Let me finish Hadoop FS -rm-r /tmp /sandbox /Mary_out star. Let me delete all the directories that are there for your Mary out, because I am not sure what are there. It is always good that you remove these things permanently. We don't need Hadoop fs-expunge either that way, or you can use skip thrash while trying to delete the directory, one and the same. That's not a problem. That's not a problem because we are in the different user, we are trying to delete that one. That's not an issue. So here, Hadoop jar, I specify myjobs.jar, and I need not give any job name here. Directly I give /tmp /sandbox /Mary and /tmp /sandbox /Mary underscore out. I need not give the job name here because inside this jar file there is only one job, and that is being given as a main class for this jar file. So no need for you to specify the job name. When you are trying to keep multiple jobs, I think you are seeing here, friends, total input paths to process 1, number of splits 1, and all job is running very comfortably. You can go to Uzi and see here in the manage jobs section, you will be seeing the job is getting executed, simple word count that is getting executed for you. I think you notice here from the terminal. So hope you understand the difference between the job that we have developed before and the job we are developing now. When we need to go with a driver class, see, driver code is required inside every job. Don't mistake me with the driver code and the driver class. This is a driver code. This is required inside every job. What is driver class? Driver class is something that is used by me here, com.sa.driver. This kind of class is needed when we are trying to keep multiple jobs inside the same jar file. Multiple jobs inside the same jar file, then we need this kind of implementation. Are you getting my point, friends, what I'm sharing here? That time what I do is, look at this one, same inside the same, I develop a Java class and you give whatever the name you want, whatever the name you want. But it's good that we give a name called driver, but it is not mandatory that you give a driver only every time. And here, this is not com.sa, this is com.myjobs. Okay. And here, we don't need all these things here. Inside this one, we only specify driver dot add class. What is that? Com dot myjobs dot mapred dot word count, and what is the this is the class name. And we specify dot class here, and here we are going to give the description. This is my word count MapReduce job, right? I save this one. Now this got executed successfully. This is fine. This got executed successfully, and you definitely might have got the output also. You want to can go to the it got successfully executed. You can go to manage Hdfs, and there you can see slash tmp slash sandbox slash Mary underscore out, and you have your partar file, and in that partar file you will be seeing all that stuff very clearly. So no problem for this. Now the same MapReduce job, what I am trying to do is, you see here hyphen skip trash, and we do that slash tmp slash sandbox slash Mary underscore out. Done. Now I am producing a new jar file, friends. Please observe this one. I'm going to I'm saying export jar and myjobs.jar, same as is. And here I am giving the main class as driver class. That's the difference. So for this jar file, what is the entry? For this jar file, what is the entry? Prasad, Ram, what is the entry of this jar file?
The driver.java.
No, driver.java file is the entry point, right? So when driver.java is entry point to my jar file, it first lands here. Here, there is a name called word count. For that, this is a class available. So in that case, we need to specify. Now, if I use the same thing, it is going to specify saying, what is that? Unknown program it is saying. It is saying unknown program. Why? After myjobs.jar, we need to specify what is the job you want to run. I want to run the word count job. Then you see, now I think you are pretty clear why we are developing two different types. So if you are developing an individual jar file for each MapReduce job you are developing, then you are going to mention that as your main class and it works as is. But when you are developing a set of related jobs together inside the same jar file, when you want the same jar file to be utilized for running all your related MapReduce jobs, and time to time you want to change the name of the job which you want to run dynamically when you're about to submit the job to the cluster, then you go with the second approach. You develop a driver class. In the driver class, you do the mapping between the name of the job and its associated MapReduce job class, and you give the description for that one so that you will be able to map. And dynamically you can decide when you are about to submit the job to the cluster which job you want to run now. I hope you are getting the point what I am trying to share with you here. Make sense, friends?
Yeah, with questions. Yep.
So this is pretty clear to you how you develop a MapReduce job on your own. You create a project. I mean, I did everything from scratch today. I think Ram, I think you are already comfortable with Java, right? So maybe it may not be that convincing to you, but as we'll be having people from different background, non-programming background even. So certain times I may be compelled to discuss things that are known to the participants already. So this is how you write your MapReduce job, and you are going to produce the jar file and run that jar file against your cluster, right? So let the MapReduce job be anything. What definitely will have? What definitely will have? What definitely will have? You will be having the job class, that is what been mentioned by me here, that is the top class. This is a job class, and inside that you have a mapper. This is inner class, more specifically a static inner class. Then we have a reducer, and then we have a combiner. Of course, combiner you want to develop separately, that is fine, but in most cases reducer itself is going to work as a combiner. Then we have a main method. In the main method, we are going to write the driver code. This is a mapper class where we have a map function. Reducer class where we have a reduce function. And the main method where we have the driver code. So let you develop any MapReduce job, its skeleton is going to remain the same. No much different. Its skeleton is going to remain the same. It's not different. Is that clear? How you develop a mapper? We have seen here very clearly. Extend your class from mapper class and override the map method. Extend your class from reducer, override the reduce method, and inside the main, either directly you can keep this entire code inside this one, or using a tool runner, you can do that, either way. But to understand all these things, you must go through the API, which I have already mentioned it to you, MapReduce API. I've already mentioned to you how the MapReduce API is going to be. Until and unless you go through that one, you will not be able to understand much. So here you have the MapReduce API. And you must go through r.apache.hadoop.conf. This is one directory, one package that you must have an idea. And r.apache.hadoop.fs is one more thing. r.apache.hadoop.io is one more package. And r.apache.hadoop.mapreduce, not MapRed. MapRed is considered to be the old API, and MapReduce is considered to be the new MapReduce API. So you need to go through MapReduce, and over a period of time, I advise you to go through its sub-packages also. This is required for the programmer. So other things we don't need, other packages and all what we are seeing here, we don't need all those things. But these things, whatever I mentioned now, are definitely required to a developer, and make sure you go through these things so that it will make more sense. Is that clear, friends?
Srinivas, I have a question here.
Yeah, please.
Earlier, when we were writing the driver class separately to execute all the MapReduce jobs, so is that like in the real-time scenario, like when we are writing one for one use case, we write all the complete set
You are absolutely right. See, for one data set, you want to process for different contexts. Data set is the same, but for each context or requirement, you want to go with a different implementation. But all belongs to the same activity, same context or same data set, something like that. Then we advise to go with one jar file and multiple jobs inside. But we rarely do different MapReduce jobs into one jar file. We rarely do that one. Maybe here for our implementation and understanding, one MapReduce job for word count, one more MapReduce job for weather data set, one more MapReduce job for all, we are packing into one jar file. This is okay. But in the production, what we do is all related. Say for example, you are working on working on a specific weblog file. Okay. So one time you may be interested to capture only the username and the IP address. Other time you may be interested to capture username, IP address and the country also. Another time you may be interested to capture few more details. For different requirements, you develop different jobs for the same weblog file, not for a different thing. All such we pack into one jar file. That is what we do at the production level.
Sure, makes sense.
But here, for the sake of understanding, what we are doing is we may be working with one more here, driver.add class, and we may be keeping one more thing here. What is that we keep? Maybe your weather temperature, the max temperature concept, what we developed, that we will be keeping here, and we bring one more Java class there. This sounds good when you're working with your examples, but at the workplace, usually we will not be doing that. Of course, your architect is going to define how you need to maintain your jar files. That he is going to define. Based on that only we decide.
Sure. Adding to that, thanks for that. And adding to that, like once we have all the jobs related to one use case in a driver class, so as I understand, in the workflow of Uzi, we will mention like, let's say we want to go through executing first one MapReduce job from this driver class, then we want to go with the other one. So in that way, you mean like in Uzi also we can mention different MapReduce jobs from this driver class, which needs to be sequentially executed.
Absolutely. Either from the same jar file or from different jar files, both. Because
sure, as per
yes,
sure.
as per your need, as per your need. Say if you go there, you go to the workflow and there, when you create, you can have any number of MapReduce jobs being mentioned in a sequence. So when you create a new one and you specify a MapReduce job there, say here, right? I'm dropping that here. So I do all my configuration where the jar file is and all. I specify the path of the jar file. I'm done with that one. You want to add anything, you can add that. Otherwise, that is fine. So you don't want to add anything, then you can leave that. So like that, you can have any number of MapReduce jobs, kept in the same as a sequence. So that is going to work one after the other. So add, now it has been done. Okay. Immediately what I can do, I can have one more. You can see that here. Here I can keep one more jar file. This is MR jobs, maybe some other jar file or maybe the same jar file. And I'm going to specify what is the mapper class, what is the reducer class and all that we are going to specify. You're getting the point what I'm saying? Two you got
Yeah.
here. I think you noticed two. This is mapper. You want to give a different name, that is always possible. You can specify here. Okay, this is my job 1. Okay, I mentioned it. And this is my job 2. Okay, this is my job 2. Okay, I mentioned that one here. And like that, I can have a series of MapReduce jobs. And in each, I'm going to specify, because I've shown you how you write the properties and all. You can add the property here. What is the property? Name of the property. What is that? What is the mapper class? What is the reducer class? What is the job name? All we are going to specify here and their values. Accordingly, they are going, that particular job is going to be executed from that particular jar file.
Sure. And do you mean like job 1 is the name of the job that we mentioned in the driver class, or is it like just a referential
No,
name that we?
this is a reference for you at the Uzi level.
Okay. In the properties, you mean you're going to mention the exact name of the
Exactly. In the
job?
properties, we need to mention that, because you noticed here. What is that you noticed here in the word count? You specified here, right? What is the set jar by this one, right? So these kind of things needs to be set there. I think you noticed here. What is a reducer class, combiner class? What is output key class, output value class? All these things need to be specified, because the Uzi specification is going to tell you what properties can be used here. They're specifying, see there, MapReduce dot MapRed dot what is the job, and you're going to specify uh, what is the class for this one. So how I come to know that these are the properties and these are the values that needs to be given, that is all been mentioned as part of your workflow specification, that use these properties and the corresponding values for these properties needs to be given for your MapReduce job. You got the point?
Sure, thanks. Yeah, I got it. Thanks.
Yeah. So please go through the thing what we have discussed in the today's class so that you will slowly gain the confidence. And what I advise you to do is, please write the MapReduce job on your own, even Ram. So I know that you are definitely comfortable, but I advise you, like how we did in the today's discussion, at least Mapper I was able to implement on my own. Same like Reducer also. You can go through the program once, twice, thrice, but write on your own so that you will understand the difficulty of working with this API, and thereby you identify where you are lagging and how those can be patched up or covered. So that makes your skill set in MapReduce to be improved, and only then you are able to write serious MapReduce jobs on your own, right? So start working towards this, and we move on to the next component in the next class because we cannot stay here forever. But I advise you to keep working on the MapReduce, and whenever you have a difficulty or a challenge, you let me know. Once you are finished with the basic things what we have discussed in the sessions, do let me know end of this session that we are done with the existing MapReduce. I give you more so that you can start working on them parallelly with your other components. Because we are not going to leave MapReduce now. Directly we are leaving, but indirectly through Pig, Hive, Scoop and all, we will be constantly in touch with the MapReduce throughout our course. Even when you come to your UZI also, we'll be touching these things. So please work with MapReduce, and you have any questions, let me know. We'll discuss those things in the next session. That makes sense,
Sure.
right? Yeah.
Srinivas, I have
Yeah.
quick question.
Please.
For the weather MapReduce job earlier, if you remember, like we had some bottleneck. You said like you wanted some intermediate file that was not allowing us to execute the weather job. Remember in the last class, you said like probably we'll pick it up in the next class.
What is that? What is that? I didn't remember exactly.
In the weather MapReduce job, I think it was in between we had some hassle in running that file to get the output. In the last class, it was asking some intermediate XML or some other. You said like we Googled it for some time and we said like, we'll see that in the next class.
Weather data set or word count? Word count, I mean, I believe. No?
Either of them. Prasad, the chance to remember. Maybe I can go through the last video and get back in the next class.
Please, once. Let me also go through that once again. Is it weather data set or the word count which we did?
I remember.
The weather data set actually, Srinivas, the log file, the XML parser. So you mentioned that it's missing in your local log file. Last class we tried to do that to XML parser.
Yeah.
That is word count, I believe, right? Word count.
It's the weather one, I guess.
Got it. So that is weblog file which we need. Weblog file.
Yes, weblog
XML format, right? I didn't got that one. You good? You remember? You made me to recollect that once again. I'll do that one now, and I'll keep that XML file ready. That is the weather weblog file in the XML form actually.
Yes.
Weblog in XML. Weblog or weblog XML.
Which has some.
Yes, got it. So that is. So we didn't got that actually. Weblog XML file we didn't got. So let me get that one. We'll run that one the same probably in the next class. At the end of the session, we'll run that one. Please remind me once again. I'll keep that ready now itself after the session.
Thanks.
Yeah. Wonderful, friends. I'll catch up again in the next session. Great time ahead.
Thank you. Have a nice day.